Hi everyone, I hope you're okay. Uh, I will be doing the November 2023 Physical Science Paper 1, guys. Ne? This is the first video. In this video, I'll be just tackling multiple choice. Please note that there will be 9 videos following this one. Ne? Each question will have its own video. Before we even start, guys, please subscribe to the channel just to help us grow and maybe we can reach a lot of learners as much as possible. Okay, we are told that a constant net force is applied to a block. Ne? Which one of the following statement is correct? If we have a constant net force, it simply means that, guys, we must have a constant acceleration, right? Remember that F net is equal to ma. If this does not change, that means the acceleration should not change as well. So the answer for 1.1 is B. Okay, and then we are told that the crate of mass m is stationary on a plane inclined at angle theta with the horizontal. Which one of the statement regarding the magnitude of the frictional force acting on the crate is correct? Okay, the magnitude of the frictional force, if you can draw a free body diagram, right? You'll have your gravity parallel here, and then you'll have your frictional force. You'll have your gravity perpendicular, FG perpendicular, FG parallel, and then you'll have the normal force. This is FK. Okay, for this thing to be stationary there, it simply means that all the forces are balanced, are together in such a way that the normal force is equal to FG perpendicular and the frictional force is equal to the gravity parallel. Hence the block is just standing stationary there. So the answer for question 1.2 will go for A as well. Yeah? Then 1.3, we're told that a ball is projected vertically upwards from the top of the edge of a building. Points P, Q, R, and S represent different positions during the motion of the ball, as shown in the diagram below. Okay, P is the starting point of the motion of the ball, is the point of projection. Q is the maximum height. We know that at maximum height the velocity is 0. R is when the ball passes the point of projection, and then S is the point where the ball touches the ground. So the velocity at S will be greater than the velocity at P and the velocity at Q. Remember that the velocity at P is the same as the velocity at R, but in different directions. Né? So between which points will the ball undergo the greatest change in kinetic energy? My answer is D. Né? Why? Because the velocity at point Q is 0 meters per second, and then here we will have a velocity which is way greater than 0 meters per second. Together. So if you can calculate the change in kinetic energy, it will be greater between these 2 points, points Q and S rather. Okay, and then I told that a ball is dropped from height h. It strikes the floor with momentum p. The ball is then dropped from the height of 1/2h. Ignore the effects of friction. Which one of the following represents the momentum of the ball when it strikes the floor after being dropped from height of 1/2h? Okay. They said we must ignore the effects of friction, right? We are told that the momentum of the ball initially is P. Remember that momentum is equal to mass multiplied by velocity. So if we can find the velocity of the ball here, we can simply find the speed as well. Okay, how can we find the speed? I know that in this case, since we are ignoring the effects of friction, this thing becomes a closed system because there are no non-conservative forces, right? Which simply means the mechanical energy at this point, let's call it point A, is equal to the mechanical energy at point B. Are you together? So since mechanical energy is conserved, it simply means that mgh is equal to the kinetic energy at B. Are you together? And then therefore, for me to calculate V, you'll just do your mathematical gymnastics, né, guys? You'll simply find out that V is equal to the square root of 2 multiplied by GH. So therefore, our momentum will be M. It's MV, right? Now we do know the value of V. So it will be M multiplied by 2 times GH. All together. Okay, and then now we look at the momentum whenever the ball is being dropped from C to D. It's still the same, guys, né? This is an isolated system, which simply means that mechanical energy is conserved. That means mgh is equal to half mv squared. Remember that, guys, mechanical energy is the potential energy plus the kinetic energy, né? Here I'm just writing the potential energy because I know what whenever my ball is dropped, there's no kinetic energy since the velocity is 0. Are you together? And there at the bottom, there's no potential energy since the height above the ground is 0. Are you together? So in this case, we can still calculate the velocity. Are you together? Remember that the height now is no longer h, né? But the height is 1 over 2 h. Are you together? So whenever you calculate, you'll find that v is equal to the square root of gh. So therefore the momentum will be mass multiplied by the velocity. Our velocity is just gh. Are you together? They wanted us to find the momentum of let's call this one momentum 2. Momentum 2. This was momentum 1. They want us to find momentum 2 in terms of p, right? Remember that p is equal to this thing. So in this case, we do not have the square root of 2. There's no square root of 2 there, né? We can have the square root of 2. If we do this, it's the same as multiplying by 1. If you multiply by 1 in maths, there's nothing you're changing. Are you together? So I will have that, and I will still have m. I'll still have m multiplied by g. Okay, and this will give me m multiplied by the square root of 2 gh all over the square root of 2, right? And remember that this guy is equal to momentum 1, so it's the same as p all over square root 2. So the answer is B there. The answer is B. Okay. 1.5, I told that a box moves horizontally, moves on a horizontal surface. The diagram below shows all the forces acting on the box. Okay, which one of the following combination of the forces do work on the box? Okay, these two will just cancel one another. Since the ball is moving horizontally, it simply means that Q and S are the ones that are doing work on the box. So the answer is B here. Okay, and then we are told that a train moving at a constant velocity towards a stationary listener emits sound waves of constant frequency. Which one of the following statements about the sound waves observed by the listener is correct? Okay, the source is moving towards the listener, so the frequency that the listener will detect will be higher than the frequency of the source. and then the wavelength that the listener will detect will be lower than the wavelength of the source. So in this case, the only answer that makes sense is A. Okay, and then we move to 1.7. We are told that Q and R are small spheres suspended by a light insulated string. When a negatively charged rod is brought closer to sphere Q, the sphere Q is repelled. When a negatively charged rod is brought closer to sphere R is attracted. Okay, this thing, guys, simply means that since there's a negative rod and that negative rod repels sphere Q, that means sphere Q is negatively charged. Are you together? And then the negative rod attracts sphere R. Sphere R is either it is positively charged or sphere R is neutral. Are you together? So I'm looking for answers whereby sphere Q is negative, number one. So that's A and D. Are you together? So B and C, they're already out of the conversation. Are you together? And then now let's look at sphere R. Sphere R has to be neutral or positively charged. There's only neutral here. So the answer for this question is D. Okay, and then now we are told that 4 voltmeters V1, 2, 3, and 4 are connected in a circuit as shown in the diagram below. Which voltmeters will have the same reading as V1 when the switch is open? Whenever the switch is open, only V3 will have the same voltage as V1. So it's not V3, rather, excuse. My answer is C. It's only this one. Are you together? Because the current was supposed to go like this. Are you together? But now whenever the switch is open, this voltage will be the same as our V1 here, and that's the only voltage which will be equal to V1. Are you together? Okay, and then now we are told that a split ring commutator connects the coil of a generator to an external circuit. Are you together? Which one of the following combinations below is correct for the magnitude and direction of the induced current? Okay, the first thing that we need to know that we are dealing with the generator here, né? And obviously the magnitude of the induced current will change. It cannot be constant, number one. And then secondly, since they are using split ring commutators, it simply means that they are dealing with the direct current, and the direct current, its direction does not change. It remains the same throughout the energy conversion that takes place. Are you together? So in this case, the possible answers are C and D. Why? Because the magnitude of the induced current changes. Are you together? And then now let's look at the direction of current. The only answer that makes sense is C. Why? Because it does state that the direction of current does not change. The split ring commutators are the one that influences the direction of current not to change. Are you together? Okay, and then now we are told that light of a suitable frequency is shown on a surface of a metal and electrons are ejected from the metal. Which one of the following is equal to the ratio of the work function to the threshold frequency of a metal? The answer is Planck's constant. Remember that the work function is equal to Planck's constant multiplied by the threshold frequency, right? So the ratio of work function all over threshold frequency has to be equal to the Planck's constant. So my answer here is just A. I really hope that, guys, the video helped you out. If there are things you're not sure about, please do write on the comment section. I'll make sure that I will address your problems. And yeah, thank you for your time. Please wait for the other 9 videos, guys. Stay tuned.